Have you ever wondered how economists really know what's going on with the economy? Well, in the next few minutes, we're going to build the exact toolkit they use to look under the hood. It's a science called econometrics. Let's dive in.
So, first things first, let's talk about the fundamental challenge every single economist faces. You see, it's one thing to have a cool theory about how the world works, but it's another thing entirely to prove it.
Right, so how do we take a neat idea from a textbook and test it against the messy, complicated real world? How do we use actual data to find out what's really driving things? Well, the answer is this field right here, economics. You can think of it as the essential bridge that connects abstract economic ideas to cold, hard data. It's what lets us move from just guessing to making smart, evidence-based decisions. And this famous quote, honestly, it gets right to the heart of the whole thing. The entire foundation of our toolkit is built on this one powerful idea. You have to constantly, relentlessly challenge your models with real-world data. Test, test, and test again. All right, let's grab our first tool. This one is all about finding simple relationships that are often hiding in plain sight, right there in a big cloud of data points. Okay, imagine you're trying to figure out housing prices. You've collected a bunch of data on square footage and price. Looking at this chart, you can kind of see the trend, right? Bigger houses tend to cost more. But how do we find the single best line that truly represents that relationship? This is where a clever technique called ordinary least squares, or just OLS, comes into play. It's this brilliant mathematical method that finds the one and only line that is, on average, the closest it can possibly be to every single one of those data points. It gives us the best possible straight-line summary of our data. So we have our line. Great. But is it any good? I mean, how much of the story is that line actually telling us? To figure that out, we need to measure its goodness of fit, and for that, we use a metric called R-squared. And this visual just lays it out perfectly. On the left, with an R-squared of 0, our line is totally useless. It explains absolutely none of the patterns in the data. On the right, though, a perfect R-squared of 1 means our model is a flawless fit. Now, in the real world, you're almost always going to be somewhere in between. But here's where things get really interesting. And a little tricky. That simple line drawing tool can get us into some serious trouble, especially when we're looking at data that's been collected over a long period of time. And I am not kidding. It can really lie. Sometimes when you plot two things over time, they can look like they're moving together perfectly, creating this powerful illusion of a relationship, when in fact, there's no real connection between them at all. So what's causing this illusion? Often, it's something called non-stationary data. The easiest way to think about this is to imagine a variable that doesn't have a steady average it always comes back to. Instead, it just kind of wanders off, like a drunkard stumbling down the street with no particular destination. A lot of big economic indicators, like GDP, do exactly this. Now, what happens when you try to draw a line between two of these wandering variables? You get what's called a spurious regression. It's just like seeing two drunkards stumbling in the same general direction. You might look at them and think, hey, they're walking together, but really, it's just a coincidence. Their paths just happen to look similar by pure chance. So how in the world do we see through this illusion? How do we know if it's a real connection or just random stumbling? Well, economists developed a really revolutionary set of tools to find out if there's a genuine connection hiding underneath it all. It's basically a two-step process. First, we have to run a formal test, something with a fancy name like the augmented Dickey-Fuller test, to confirm if our variables are in fact wandering. If they are, then we move on to step 2. We start searching for that hidden long-term connection between them. And this hidden connection has a name. It's called co-integration. Honestly, the best analogy for it is a person walking a dog on a leash. The person can wander, the dog can wander, and in the short term, their paths might look pretty random. But because of that leash, they can never, ever get too far apart. They're tied together in the long run. Let's see how this works in the real world. Now, this table might look a bit complex, but the goal here is actually quite simple. Economists are just trying to figure out if different types of oil prices, like WTI and Brent, are co-integrated, if they're on that same leash over the long term. And this is where we see the real art inside the science. Just look at the results for WTI oil. See how one test suggests there are 4 long-run relationships, but the other one suggests only 3?
This shows why an economist's judgment and interpretation are still absolutely essential. You can't just blindly follow the output. Okay, so once we've established those true long-run relationships, we can unlock an even more powerful tool. This one actually lets us trace the ripple effects of a single economic event as it moves through the whole system. These charts are called impulse response functions. Just check out the top right chart. It's mapping what happens to GDP, that's LGDP, over the next 50 months, all because of a single unexpected shock to government revenue, or LREV. We can literally watch the economic shockwave play out over years. It's so cool. For our final tool, we're going to look at something that gives us an even more powerful lens. It works by combining different dimensions of data together, which gives us much richer, more robust analysis. So far we've talked about looking at one thing over a long time. That's time series data. Or looking at many things at one single moment. That's cross-sectional data. Well, panel data is really the best of both worlds. It lets us track many different things over many different years, all at the same time. Here's a super simple example. We're tracking 2 different counties across 2 different years. Now, this structure is incredibly effective because it lets us control for the unique, unchanging things about each county while also analyzing how things are changing over time. It just gives us much more reliable insights. So, we've gone from drawing a simple line on a chart to mapping these incredibly complex economic shockwaves. This ever-evolving toolkit is exactly how economists turn a theory into testable, data-driven evidence. It's how they find real proof in a messy world of numbers, and it's what they'll use to try and solve the next great economic mystery.